Hello students, here today in question number 3, first exercise 1.1, find the LCM and HCF of the given integers by applying the prime factorization method. We need to apply prime factorization method, right? Now in 12, 15 and 21. For 12, 15, 21, as we do prime factorization, for 12 we have 2 times 6, again we do 2 times 3 and 3 times 1, so we can write 2 times 2 times 3, right? For 15, what we have, 3 times 5 and 5 times 1. For 21, we have 3 times 7 and 7 times 1. So we write here 3 times 5 for 15, 3 times 7 for 21. Here to find HCF of 12, 15, 21 is, if you observe carefully, here we have 3 as common in all the 3. So our answer is 3, right? Now similarly, LCM of 12, 15, 21. Here we have this 2 times, so we write 2 times 2, and we have in 3 common 3, and then we have 5 times 7. So our answer is 2 2s are 4, 3s are 12, 12 5s are 60, 67s are 420, right? That's it. Here we no need to verify. Now we go for next question. Similarly, for 17, 23 and 29, 17, 23 and 29 are prime numbers, right? So we have 1 times 17, 1 time 23, 1 time 29. So HCF of 17, 23, 29 is 1. Do you see 1 is common? And similarly, LCM of 17, 23, 29 is 17 times 23 times 29. So what is the answer, dear students? 17 times 23 times 29 is 11339. Here there is notes for you, dear students. If P, Q and R are prime or co-prime, then HCF of P, Q, R is 1 and LCM of P, Q, R is P, Q, R. Do you see? These 3 are prime numbers. So here we have HCF 1 and this product of these 3 numbers, right, for LCM. So remember these notes. They may ask you for 1 mark objective, okay? Next. Similarly, we go for 8, 9, 25. So we can write 8 as 2 times 2 times 2, 9 as 3 times 3, and 25 as 5 times 5. Do you see? I just said co-prime numbers 8, 9 and 25, they don't have any common, right? So we have HCF of 8, 9, 25 is 1. When there is no multiple common between these 3, when there is no factor, so we write 1, 1, 1, okay? This we actually, we basically don't mention here, so you just remember this, okay? Now similarly, LCM will be of 8, 9, 25 is 8 times 9 times 25. So what is your answer? 8 times 9 times 25 is 1800. Okay, question number 4. So they gave you HCF is 9 and we need to find LCM, right? There is during here, if you see, we use fundamental theorem of arithmetic. I am writing formula. Theorem of, what do we write? Arithmetic, and that is HCF of two numbers times LCM of two numbers is product of these two numbers. So HCF is given how much? 9, right? So HCF of 306 657 times LCM of 306 and 657 equals to 306 times 657. So what we write here? 9 times LCM of 306 657 equals to 306 and 657. So this 9 will go that side and become divide. So we write LCM of 306 657 equals to 306 times 657 divided by 9. Okay, now we divide this 9 is 306. So what we have? Just do it. 306 divide 9, we have what? 34. So our answer is in 34 into 657. Just multiply and write the answer. So we have 22338. So you got your answer. Okay, now we go for next question. Check whether 6 power n can end with the digit 0 for any natural number n. Okay, here there are two ways that I will explain you. Okay, first we go for method 1. There is a trick and there is a method. Okay, if you observe carefully here, 6 power n, can I write like this? 2 times 3 whole power n. So it means it is 2 power n and 3 power n, right? Here 6 power n don't have factors 2 power n and 5 power m. Hence 6 power n will not end with 0. Dear students, remember, see, I will give you a few examples. Okay, examples. If you observe carefully, 20, when I factorize this 20, 2 tens, 2 5 5 ones. Do you see there are factors? Like if I write 20 as in prime factorization, 2 times 2, 5 times 1. So we have 2 and 5 factors, right? So when there is a number ending with 0, you will have factors 2 and 5 compulsory. So if you observe carefully, here we are having 2, but is there 5 here? No. See, there will be no number that will end with 0 when you have power n. Okay, similarly, there is one more method. I will explain method 2 for you, dear students, and this is very easy and it is fantastic method. You just, what you do, they said natural number n, right? So for n equals to 1, we have 6 power n as 6 power 1 as 6. For n equals to 2, we have 6 power 2. 6 times 6 is 36. Similarly, for n equals to 3, we have 6 power 3, right? So 6 times 6 times 6 is what? 216. So this will go on. So from the above results, we can say 6 power n will not end with 0. Okay, great. Now we go for question number 6.